Again, welcome to Principles of Epidemiology course. This lecture is an overview of epidemiological study designs, and it covers chapter 6 of our course textbook. So there are two types of epidemiology. We have descriptive and also analytic and scientific. With descriptive, our main objective is to monitor the public's health and also to evaluate the success of intervention programs. Also be able to generate hypotheses about causes of disease. Now with analytic or scientific epidemiology, we are going to evaluate hypotheses about the causes of disease and also to be able to evaluate the success of intervention programs. So with descriptive, we may ask a question like who, where, and when. So it will be based on the person, time, and place. But with analytic, we can answer a question like why or how, because with analytic epidemiology studies, we try to find out the causes or the relationship or the association between the exposure and the outcome. So we want to understand the causes. But with descriptive, our main goal is again to just understand the main phenomena of the problem. And the goal here also is to generate the hypothesis about causes of disease. And then analytic, we evaluate the hypothesis. So with descriptive, we identify and also count cases of disease in population according to person, place, and time. And we conduct simple studies. So with descriptive epidemiology, the study designs we may have is case report and series. This is a very simple study design, and we shall go through it. Also, the cross-sectional studies. Cross-sectional studies also is called the prevalence studies. So here we say with descriptive, we are going to identify and count cases of disease in population. So that is finding the prevalence or the incidence. So that's again, the cross-sectional studies. Our main goal is to find the proportion of the population that have the problem or the prevalence. So this means we have to identify and count the cases of disease against the population or in the population, and that will give us the prevalence. We also have ecologic study, which is almost the same as a cross-sectional, but the difference is that in ecologic studies, our unit of measurement or our observation is based on grouping. So we may say all male or all female, or we may say all particular group of people in a particular age group, etc. So ecologic studies based on grouping. And we shall go through this in detail. So as we said, with the analytic and or scientific, we are going to compare group and systematically determine if there's a relationship or association between the exposure and the outcome. So with analytic, we need to evaluate the hypothesis about the causes of disease. That's the main goal. And with descriptive, the main goal is to generate hypothesis about causes of disease. We generate in descriptive and we evaluate in analytic. So with the analytic epidemiology studies, we have the clinical trial, experimental study, case control study, and also cohort study. And we shall go through each one. So our main learning objective in this lecture is to begin to understand the key components of all analytic studies. Also begin ability to identify main types of analytic studies. Also begin to understand the key features of experimental, cohort, and also case control studies. And also begin to understand the strength and limitation of each studies. So the goals and design decision in epidemiological research. Here we say we conduct an epidemiologic study to determine the relationship between an exposure of interest and the disease or the outcome of interest with validity and also the precision using a minimal amount of resources. So that would be the main objective of an epidemiologist or epidemiological study. The goal is to find a relationship or association between an outbreak or exposure, or it can be a risk factors against the outcome or the disease. We want this relationship to be valid. Also, we want to use a minimal amount of resources as much as possible, minimal. So now we have a question: in which people we want to conduct an epidemiology studies? In which people? We have to clarify that. It can be based on different categories, either by gender, age, geographical area, socioeconomic status. It depends on the disease or the exposure or the risk factors that we are studying. And also, how should you define your exposures? And also, how should you define your disease? And how can you make your study accurate? For example, we need to find a way to eliminate biases. If there's any bias can come from the sample selection or the instrument that we are using to measure our variables. Also, confounding variable. This can be a third or locking variable that can create an association between two exposure and the outcome, whereas it's not there. And also the random error. Then how can you make your study efficient? So again, as an epidemiologist or a researcher, these are the 5 questions we can again try to answer. How should you define your exposures? In which people we are doing the studies on? How should you define your disease? And also, how can you make your study efficient in terms of resources? And how can you make your study accurate? In our next future chapters, we are going to cover the bias, which is chapter 8. Then we go to confounding topic. And again, that's a chapter by itself, and we may go more detail here. So these are the components of a study. We have a population, exposure, outcome, also potential confounders, and also analysis, and then communication of findings. And we shall go through each of these components. In any study, especially epidemiological study, surely we are going to work on the population because our goal is an exposure to an environment, or there are some risk factors to environment or a population. Those are the exposures. What is the outcome? The disease, and also potential confounders. There are some characteristics of, again, the population that may contribute to the relationship between the exposure and outcome. So we start with the population. The source population is the population you are interested in knowing more about. So that is called the source population. It's the population you are interested in knowing more about. Then we have the study population. The study population will be the population you enroll in your study to represent the source population. So again, a population that we enroll in our study to represent the source population will be the study population. So for example, we consider the nurses' health studies. And here we say there were scientific and also practical reasons for selecting these study populations. Also, generalization, very important. Assuming association in a study reflect the truth, to whom does it apply? So normally in the studies, we may consider, let's say, the nurses' health studies. We consider some participants. It will be a sample. We cannot use the whole population for a study. By the sample that we get, we will make sure that the sample represent the population. And by saying represent the population, that will be after we finish our studies, the result we get using the sample, we apply the result to the population. which is the concept of generalize. So the outcome, here we say the case definition will equal to description of the event you are interested in studying. And this can be a disease, it can be a defect, injury, event, or a state. So this is just a terminology we should know. A case definition is the description of the event you are interested in studying. Again, this can be a disease, defect, injury, event, and state. Let's say we have a case that we want to know if the exposure, smoking cigarette causes lung cancer. In this case, smoking cigarette will be, again, our exposure, and the outcome will be lung cancer. So that will be our case definition. We have example here, a man with a cardiovascular disease defined by ICD codes will be, again, a case. Or a woman with first occurrence of breast cancer identified in a cancer registry also can be a case. An infant with a structural abnormality of the heart identified within the first week of life, again, that's a case. So again, a case definition is just a description of the event. And this can be a disease, a defect, injury, etc. Now, the goal is to minimize errors. Always in the studies, the main result, we want to make sure is valid and error-free. The precision, accuracy is perfect. But again, in most studies, as we shall see as we go, there's no anything we call the perfect studies. But the goal, again, is to minimize errors. So next is the exposure. What is exposure? That will be the determinant of interest upon which an outcome depends. So the outcome depends on the exposure. I'm exposed to cigarettes, my outcome will be lung cancer. If I'm not exposed to cigarettes, my outcome will not be a lung cancer. So determinant of interest upon which an outcome depends. This can be constitutionally, or it can be environmental or behavioral. So exposure is the determinant. So an example we have here is genetic polymorphism or female sex. It again depends on what type of study we are doing. Maybe we may have some outcome or disease that can be affected based on your gender. Example can be a breast cancer. They are more female than male. So again, exposure can be genetic polymorphism, female sex, short stature. And also we have a fluoridated water if we are exposed to it, or air pollution, we are exposed, what will be the outcome? Passive cigarette smoke, or cigarette smoker, or illicit drug user, also fitness person, or high fiber diet. So these are all can be exposures. Again, the main goal here is to minimize errors. Now, what is a potential confounders? First, let's go through the definition of a confounder. Here we say a confounder is an extraneous determinant of an outcome. Can be constitutional, environmental, and behavioral. Now, a confounder normally will be, for example, if we have two variables, exposure and outcome. Cigarette smoking, one variable, causes lung cancer, the second variable. Now, a confounder can be a third variable that can create an association or relationship between exposure and outcome. So, for example, let's say in Florida, during the summertime, we have a lot of shark attack. Shark attack increases during the summer in the ocean, in the beach. During the cold weather or a little bit cold weather, shark attack is less. Also, we know that in summer, ice cream sales also goes very high. The sales of ice cream during the summer is high. So we can see that in the summer, there's a relationship between shark attack and the sale of ice cream in Florida beach area. But that doesn't mean that, again, when I smoke or when I buy ice cream and I go to the beach, I'll get bite or I get attacked by shark. Or if shark attack me, I'll go and buy ice cream. No. So here we have a confounding variable that is causing the relationship. In this case, it can be the temperature. So the temperature goes high, sales of ice cream goes high, shark attack also goes high. So that's again the concept of a confounding variable. So here they say confounders may lead to distortion of true association between exposure and outcome. Because with this confounding example, we can see that there's a relationship between ice cream sales and shark attack. During the high temperature, both of them increase. When the temperature is low, both of them goes down. But the confounding variable is the one causing it. So the goal here is to identify confounders and control them in some way. Again, we are going to cover a chapter by itself, a confounding chapter by itself. And the only thing we're going to mention here is that we can say the key word here is control. We cannot eliminate confounding variable in any studies. Our main goal always is to control it. And also, if possible, we identify them. And also, we have a term called the residual confounding. Residual confounding variable means a variable that remains in a study when we're trying to, again, minimize it or remove the confounding. Still, we may have a residual confounding. So this is an example given to us. We have a pesticide level goes with the breast cancer. So there's a relationship between pesticide level and breast cancer. But actually, the age of the people involved may contribute to this two relationship between pesticide level and also the breast cancer. So our age will be our, again, confounding variable. The next component is analysis. Analysis is very important. That's the main stage. So here is the examination. Most of the time, we are going to use the software. Examination of your study data. Then also estimation of the measure of disease frequency and association. So here we can describe your study population. We can do our crude estimates. This is if no confounding. A crude estimate means we are using the whole data as one unit, one variable, one unit, and we analyze it. Okay, there's a relationship between age and disease A, or there's a relationship between gender and disease A or disease B. Here we take the data and we analyze it once. We are not going to consider the age of the participants or their status, income, etc. Now, if we are not sure or we think there's a confounding, then we do what is called the adjusted estimate. In this case, we need to consider more variables or the characteristics of the participants that we think may be related to the disease. And there are three ways we can do this: either standardization, or stratified analysis, or multivariate analysis. Multivariate analysis, we can use something multiple regression analysis. Again, we may discuss this in the future lectures. Stratified analysis means we may break variables or the participants' characteristics into 2 or 3 parts, and then we test each one with the outcome. So also we have what we call the communication of findings. So communication of findings is telling the appropriate persons or community what you found, even if you found no association. We can know many researches or studies. At conclusion, maybe we may not find what we are looking for, but whatever we arrive to, we have to give our conclusion on that. And also we can communicate our findings, mostly in the peer-reviewed journals to publish it, or we may have a workshop or go to a conferences to give a presentation. Can be in a meeting or government reports. And also, what about popular media? Also possible. So how to decide on study design? So that's our first question. I have some objective. I want to do some studies, identify some problem, but how can we choose a specific study design? So that's where we're going to start with. So there are types of analytic and scientific studies. We have so many. We have the observational and we have experimental. Now, the difference between the two, experimental, we can almost eliminate the confounding variables. We can also manipulate the inputs to determine if there's any variables or confounding. But it's very expensive and require a lot of resources. In these experimental studies, we must have the lab and the instruments to do our studies. Observational study, again, we are observing our participants, and if there's any intervention, etc., we may give. But the disadvantage of this is the confounding variable. Advantage, less expensive. Experimental, more expensive. So let's look at experimental. We say the investigator actively can manipulate which group receive agent under studies. So again, we can manipulate the input, the exposure, increase, decrease it, etc. And two major types of experimental studies is the clinical trial and also experimental study. With observational, the investigator only can observe as nature takes its course. And we have the cohort studies and case control studies. So with experimental study, we said the purpose is to study preventions and also treatment for disease. And the key feature for experimental study will be, again, the investigator can assign individuals to two or more groups that either do or do not receive a preventive or therapeutic agent and follows the group for incidence of outcome. The setting can be, again, we have to be ethical issues and feasible issues must be considered. So ethical and feasible, and small effect expected. And as we said, with experimental study, again, resources is the main issue. So money should be available. Now we have experimental study example here. So first we start with the source population, the population we are interested in studying. So we have the source population. Then we may divide into two. We may have the treatment group. Then we have the comparison group. So here the investigator assigns the people to groups, usually by randomization. Experimental, again, normally goes by randomization. So we have the treatment group and then comparison group. Then we give the treatment group whatever treatment program or agent, dosage, etc. we give to them. Then we monitor them for some period of time and see the outcome, what to be the outcome. Comparison group also, we monitor them for some time. Here, this group doesn't have any treatment, but we want to compare the two outcomes. So here we say incidence of outcome will be the disease occurrences and also the symptom improvement, survivor, or side effects. These are what we are going to look at the treatment group. Then we compare it with, again, the comparison group. Now with the cohort study, a cohort study is observational studies, and we have two major types. We have the prospective cohort studies, which means we have the participants now and we monitor them into the future, see if they may have the problem, the outcome, the exposure and the outcome. Then we have retrospective. Retrospective means the participants already have the outcome, the disease, So we are looking at their historical behavior. We look at the historical data to see why they have the disease at the present time. So with the cohort study, one will look at the future and the other will look at the historical data. Now, the purpose of cohort studies, here we say the studies causes, also the preventions, and also the treatments for diseases. And the key feature will be investigators select subjects according to their exposure levels, and then we'll follow them for disease occurrence. The setting can be try, not ethical, and feasible, or too expensive. So here we have mostly moderate or large effect expected. Little about exposure, and so can evaluate many effects of an exposure. So exposure is very, again, rare in this case. One disadvantage of cohort study, again, is the period of time, and we may have an attrition, and maybe some of the participants in the group may decided not to be in the group no more. So this is a diagram example of cohort study. We have the source population and we have the exposed group. So here the investigator will select the exposed group and also comparison group. Then we monitor the group, the exposed group, for some period of time and see the incidence of outcome, then compare with the comparison group. Now, timing, here we talk about timing. As we said, prospective cohort studies will look at the future. So we have a cohort study. The studies start from here. We have the exposed and unexposed. We compare the incidence of disease for exposed and unexposed after some period of time. But with prospective, the start of the studies, and we look at the future, what will be the outcome. Now with retrospective, we compare the incidence of disease, which means when we start, the participants already have, those who have the outcome already. So now we are looking at the past data, what led them to this point at the present time. So we may look at their historical behaviors, whatever disease or studies we are doing, we compare. So also we have what we call the case control studies. So this also the study causes, prevention, and treatment for disease, same as cohort study. And the method of sampling a population where subjects are identified as having the disease, which will be the cases, or from a source population that gave rise to the cases, which is the controls, and also exposure distribution is compared. So with the cohort study, we have one group exposed and the comparison group. But with case control, we are going to study two groups. Those with the disease case and those without the disease will be called the control. The setting normally is try not ethical, the trial not ethical, feasible, or too expensive. Also, it can be moderate or large effect expected. And let them know about the disease, and so you can evaluate many exposures. Normally, we do case control when the disease is not common or it's a new disease. So that's why we have the case and the control. So here we have the source population, and the participants with the problem or the cases of disease, and we monitor with some period of time. The outcome, again, the investigator select the cases and the controls. Controls are sample of source population also. So here are the graphical, again, representation of the three study design again. So we have the experimental studies, the source population. We select the treatment group and comparison group. Monitor them within some period of time and see what will be the incidence of outcome. Now with cohort, we have the source population, the exposed group, and comparison group. But again, cohort is based on observation. So investigation selects exposed and comparison group, and we give whatever intervention or program and monitor. Then the case control studies, we have the cases and we have the control. Cases are the participants with the exposures who are exposed, and controls are the participants who are not exposed. And then we see the outcome determines and compare the exposures. So now a question says, which type of design is being described in each of the following scenarios? So we have a first study, a study that evaluates the relationship between breast cancer and a woman's history of breastfeeding. So the investigators select women with breast cancer and an age-matched sample of women who live in the same neighborhood as the women with breast cancer. Then the study subjects are interviewed to determine if they breastfeeded any of their children. So again, the main goal is we are trying to find out a relationship between breast cancer and a woman's history of breastfeeding. But here, the investigators select women with breast cancer and an age match sample of women who live in the same neighborhood as women with breast cancer. And the study subjects are interviewed to determine if they breastfeed any of their children. So again, this will be case control studies, because we have those women with the breast cancer and those with that also. And we match the control with the women. When we say we match, for example, if the women age must be around the same age group, the geographical area must come from the same area, etc. Now, the second one is a study that evaluates two treatments. Again, two treatments for breast cancer. Women with stage 1 breast cancer are randomized to receive either lupectomy alone or lupectomy with breast radiation. So there are two treatments. Now, women are followed for 5 years to determine if there are any differences in breast cancer recurrence and survival. Now, because we have 5 years to monitor the two groups, this will be a cohort study. Normally, as we said, the first one is case control. The reason why it's case control, we have the case, women with breast cancer, and the control, women without it, but both of them breastfeed. And we evaluate the two, compare the two, and see the results. But in second one, we have women and we give them different types of two types of treatment. And we monitor them for 5 years. So that's a cohort studies. The key word is monitoring them for a long period of time. The third one is a study of a relationship between exposure to chest irradiation and subsequent risk of breast cancer that was begun in 2010. Now, in this study, women who receive radiation therapy for postpartum metastasis in the 1940s were compared to women who received non-radiation therapy for postpartum metastasis in the 1940s. Now, the women were followed until 2009 to determine the incidence rates of breast cancer in each case. Again, this will be a cohort studies, since both women have the problem. So in this study, women receive radiation therapy for postpartum metastasis 1940 were compared to women who receive women who receive non-radiation therapy for postpartum. So we have two different treatments. The women were followed, but both women have the case, but they received two different treatments. Then in this case, and they were followed for some period of time. So this will be a cohort studies. Now, case controls come when, in this case, if this is a case control, it means we have women who have the problem and the women who don't have the problem. Then that will be, again, case control. The cases are women exposed that are exposed, control will be women that are not exposed. Now, the next one is the study of a relationship between exposure to post-menopausal hormotherapy and subsequent risk of breast cancer. That will begin in January 2016. So now in this study, the post-menopausal women who receive hormotherapy during 2016 will be compared to post-menopausal women who not receive this therapy. The women will be followed until 2026 to determine the incidence rate of breast cancer in each group. So again, this also will be cohort studies. So consideration for choosing a particular design, we say the research questions. We need to consider the type of research questions, the hypothesis. And we may have a study that we don't need to, again, evaluate the hypothesis. So in this case, we can use the descriptive study, epidemiology studies, which will be case series, case series, and also prevalence or selection cross-sectional studies, prevalence studies. Also, next thing, existing scientific knowledge, frequency of exposure and disease or outcome is very important. We need to consider. Then ethic issues consideration. Also, we should concern about the validation, the random error, confounding error, efficiency. We should also consider about the resources, etc. So here we say you will find that no study design is perfect, but we should not let that stop us from conducting the best possible research to answer our public health questions. So that will be our final note here. So again, in this course lectures, we discuss about the epidemiological study design, which again focus on the analytic epidemiology or scientific epidemiology. So evaluating, again, the hypothesis. In our previous lectures, we discussed about the case report, case series, cross-sectional studies. Those are for descriptive epidemiology studies. And in these lectures, we focus on experimental, case control, and cohort study, which is to evaluate the hypothesis. So it's analytic epidemiology studies. So again, thank you for your time. And if you have any question, you can post it in the Blackboard.